Throughout most of the world, arachnids form an integral part of the fauna. Arachnids include scorpions, whip scorpions, sun spiders, tailless whip scorpions, and spiders. The feeding behavior of arachnids involves the use of modified appendages for capturing and macerating prey. Limb movements are controlled by hydraulic pressure. Defense behavior varies among arachnids, but may involve the exoskeleton, specialized appendages, chemicals, or injected toxins. Spiders are among the best-known arachnids and exhibit most features common to arachnids. Among spiders, tarantulas are best known because of their large size and threatening appearance. The eyes contain a combined cornea and lens. Hairs on the appendages and body are the most important sense organs, serving a tactile function. The abdomen is covered with hairs that have an additional function, defense. These are called urticating hairs. This tarantula has brushed some of these hairs off of its abdomen with its hind legs. The hairs are barbed and easily penetrate the skin of potential predators, causing irritation. The paired spinnerets are used for forming strands of webbing. Respiration takes place in book lungs. Paired chelicerae are the first set of appendages. The second set of appendages, the pedipalps, are used to help manipulate prey in most arachnids. The chelicerae have fangs which are used to inject poison into prey. In this respect, spiders differ from other arachnids. A combination of pedipalps modified into large pincers and an elongated abdomen terminating in a stinger distinguish scorpions. Small scissor-like chelicerae are located on each side of the mouth and are used to macerate prey so that the liquid contents can be ingested. A number of eyes function as light sensors. The large pincers manipulate prey. Much of the body, including the tail-like structure or telson, is covered with sensory hairs. The telson terminates with a pointed stinger, which is used for subduing prey and for defense. A pair of comb-like structures, the pectins, perform a sensory function, allowing the scorpion to detect microvibrations on the substrate. Ventrally located book lungs perform respiration. Defense consists of a threatening display with possible attack. The scorpion can inflict a painful sting. Scorpions hold their prey with their pincers and inject a lethal dose of venom. The chelicerae and pedipalps are the primary appendages involved in feeding. The legs and pedipalps perform many functions, including digging of burrows. Despite their threatening appearance, very few scorpions inflict stings dangerous to humans. The most striking feature of the sun spiders is the extreme enlargement of the chelicerae. Each chelicera is divided into a dorsal and a ventral part, which articulate vertically. These are used to capture and macerate prey. The pedipalps perform a sensory function and are used to seize prey, bringing them into contact with the heavily armored chelicerae. Prey capture and manipulation are rapid in sun spiders. Muscle contractions move the liquefied prey into the gut. Spherical white eggs are visible through the translucent abdomen. The eggs are laid in underground burrows. Some arachnids, including scorpions, bear live young. In many arachnids, there is prolonged parental care of the young. The sun spider extracts all of the body fluids of the prey, leaving only the crushed exoskeleton. Tailless whipped scorpions resemble spiders with their flat bodies and long legs. The pedipalps are raptorial, capturing small prey by grasping them and puncturing the body with the many sharp spikes. The chelicerae are spider-like. The first pair of non-feeding appendages serve as tactile sensors. Usually one is oriented toward a moving object. Prey manipulation and feeding are similar to other arachnids. Whip scorpions, also called vinegaroons, move slowly, using the first pair of non-feeding appendages as tactile sensors, very much like sun spiders and tailless whip scorpions. These heavily armored arachnids differ from others in possessing a thin, elongated sensory structure, the flagellum, on the terminal segment of the abdomen. The primary defense mechanism of whip scorpions is the ejection of acetic acid from anal glands. Whip scorpions spray the acid toward the predator. Blue litmus paper turns red in response to the acid. Prey are captured in a manner similar to that of tailless whip scorpions. The armored pedipalps grasp and crush the prey. The prey is macerated by the chelicerae and the body fluids are ingested. As in other arachnids, the chelicerae and pedipalps are the primary feeding structures. Drinking in arachnids is a slow process. In this whip scorpion, water moves up the pedipalps through capillary action and into the mouth. In some arachnids, water can be absorbed directly through sutures in the exoskeleton. The exoskeleton is generally covered with a waxy coat, which helps reduce water loss from the body. Following feeding and drinking, a ritualized cleaning behavior removes debris from the appendages. In summary, the shape and relative size of pedipalps and chelicerae vary among arachnids. However, in a general way, their functions are similar. Defensive behavior also varies, often involving different structures as well as noxious secretions and injected toxins. This combination of characteristics has allowed arachnids to successfully exploit the terrestrial environment for more than 400 million years.